at your...
So I want you to kind of think about this. I think it's helpful to think about why we factor in the first place. Sometimes I feel like in algebra we put undue emphasis on factoring, but factoring is just a tool. That's the only thing it's for. I mean, there might be some rare instances in calculus and beyond where we factor for other reasons, but almost always we're going to factor to solve equations, right? And so before we even go into this, I want you to kind of keep in mind that we're going to, like for a problem like this, we want to factor it because we want to, this is the analog of the problems we did earlier with quadratic functions where we tried to break it into two small factors and then apply the zero product property, right? And then once we get it factored, we get a series of small factors whose product equals 0, and then setting each of those small factors equal to 0 is no big deal, right? That puts us in a place where we can easily find the solutions. Okay, but when we're factoring to solve a polynomial, we got to always kind of think about when do we want to bail off the factoring train and just solve this thing, right? Because sometimes we can overdo the factoring. It's really only useful until it gets us to a place where we can solve the mini equations that we get from applying the zero product property, right? So keep that in mind. Okay, given that, and I'll kind of bring that up throughout the day as we look at some of this stuff. So how are we going to deal with this one then? So by way of a strategy here, what's the first thing we always want to probably try? So we'll simplify, right? So do you see something up here that, okay, so if this is an equation, maybe you see something right away you could do. So we could divide by 3, for example, which would be a great idea. Let's just pretend for a moment that we can't do that. We can, but let's pretend we can't. Because actually what I did is this is the section 6.4, we just skipped 6.3. 6.3 was about, I showed you guys Pascal's triangle yesterday, right? That's really what 6.3 is about, is Pascal's triangle and the binomial theorem, and we're going to skip the binomial theorem part for now. But 6.3 never really asks us to solve equations, it just asks us to factor equations completely. And so if we were solving this, yes, we would divide both sides by 3 to make things simpler, and that's a great idea. If we're factoring this, remember that the end result has to be a series of factors whose product is exactly what we started with. Okay, so I can't really divide by 3 if I'm factoring. What can we do? Okay, and glad to bring that up. Even if this were, okay, let's run a parallel experiment on this side of the board where we've got 6x cubed plus 15x squared plus 6x equals 0. And let's divide each side through by 3x, how about? By the 3 and the x that were both suggested. So on this side, we're just going to get 0, right? On this side, what are we going to get?
2x.
Okay? And now what? Say it again. Yeah, solve it like a quadratic. So what are our options for solving it like a quadratic? Okay, if we can factor easily, we'll factor. Otherwise, we'll do something else, right? Unless I could point to a single x, and if I can point to a single x, what can I always do? Isolate it, right? But I can't do that here, right? So we could certainly use the quadratic formula, right? Or we could complete the square, something like that. Could we factor this? So factoring, it looks like this is going to be a bottoms-up type problem, right? And we could do it that way. But look at what we got going here. We've got a 2x squared and a 2. There aren't very many convenient factors of 2. In fact, there's only one convenient factor of 2. Everybody agree? It's 2 and 1. So this is one where we could kind of even do like a little trial and error thing, right? We know that maybe it's going to work, maybe it's not, but we could try it real quick. If we're going to break this thing apart, what's the only thing that the first 2 terms could conveniently be? X and 2x. Yeah, they got to multiply to 2x squared, right? So I know I'm going to end up with a 2x and an x. Well, what are the only possibilities? I know that if the last term is positive, C is positive, and B is positive, what's that tell me about the sign of the numbers? They're positive for sure, aren't they? I've only got two possibilities, don't I? Right, for factors of 2. If it's going to factor. Now, it might not, right? But if it does, what are my two choices? 2 and 1, right? So how about if we just try both scenarios and see if one of them works, right? Maybe the first number is 2 and the second number is 1. Let's just see if that foils out properly. So what are we going to get? That would give us 2x squared plus 2x plus 2x. That's not going to work, is it? Everybody see that? I'm going to get my cross term is going to be 4x instead of 5x. Right? Yes?
4 and 1.
Well, we can't. 4 and 1 don't multiply to 2.
I was talking about problems of multiplying A and C together.
Well, yeah, okay, right, but we could do bottoms up, but I'm just going to show you guys a little shortcut here, right? So we can just, do you see what I'm doing here? All I'm saying is, because if this were a 12 and that were like an 8 or something, this might not be a good idea because there's a lot of different factors that make up 12 and quite a few that make up 8, right? And so we'd have a pretty long list of things to try. That's not worth it. But if it's something like this where I have something other than 1 for A, but it's something like 2, where it's got only 2 discrete factors and that's it, right? There's really no other option. Then, and the same thing here, right? 2, the value of C is also really limited in the way that it factors. Then why not just do a little, trial and error and see if one of the two possibilities works? You understand how these numbers don't work, right? Let's just, if I try to expand this out, I'm going to get 2x squared plus 2x plus 2x plus 2. Well, 2x plus 2x doesn't give me my necessary 5x, right? So these guys lose. What about these? 2x squared plus 4x plus x plus 2. That works, doesn't it? Right? You see the point? So this was probably quicker than having to use quadratic formula or something like that, right? So what are our solutions then? So what's this one going to equal if I set it equal to 0 and solve? If I apply the zero product property? Well, you can do it in your head, right? If I set that factor equal to 0, what are the 2 steps to isolate x? What's the first thing I got to do? Subtract 1 and then divide by 2. So x equals negative 1/2. Okay. Or how about this guy? Negative 2. Okay. So we got some solutions, right? Let's go try it the other way and just see if we get the same stuff. All right, so let's not divide by 3, even though we could. Let's not. But what else could we do if we're just talking about the factoring part of this? It's been a while since we've done a lot of factoring. But what I tell you always want to try to do first. So it always makes life easier. Well, I mean, yeah, maybe. Maybe we're going to start looking for some patterns, but there's something even beyond that. We always look to do the very beginning. What do you think? Remember, when I'm factoring, I'm just trying to break this thing into pieces, right? Is there something I can undistribute? An x, right? That's the important thing, is I can take an x out. Is there a number? 3, yeah. You always want to see if you can factor out a greatest common factor, a greatest, and it's always get like a monomial factor. So it's a single, we're going to end up with a one-term factor out front. The process is literally undistribution, but in math that kind of sounds dorky. We talk about it as factoring out a GCF, or a greatest common factor. So does everybody see I could take away each of these has an x. The smallest common power of x is x to the 1. So I could factor out an x, and then numerically 3 divides into all those, right? So I could do this. And then I could do, you should do that in one step. One step is fine. You don't need to make that 2 separate steps. Just factor out a 3x. Okay, why is that helpful? That's really helpful.
So, I mean, that's.
Yeah, it makes this one a quadratic, doesn't it? Quadratics, we're great at quadratics. We know a million ways to solve a quadratic. And then we get this monomial factor out front, right? And so from here we have a choice. You know, we could stop there if we want to and say, all right, so now we've got this broken into two factors. I could set the first one equal to 0 and solve, and the second one equal to 0 and solve. And the second one, the work's already done right there, isn't it? That's what we just did on the other side, right? That equation right here, one more time, that equation right there corresponds to finding the 0 of that factor, doesn't it? Right? So we could factor or not, it's up to you guys. I mean, we factored, it was pretty easy to do, so we could just continue riding the factor train down to here, but then that's where we'd stop. So I want you to see something. There's another really important lesson that we accidentally learned there too, which is really a good one. How many solutions are we getting over here? Well, what are they? What's the solution to that first factor? 0. That one we already got, right? That's x equals -1/2, and x equals -2. How many factors did we get? How many solutions did we get? 3. How many did we get over here? We lost one. How?
Wait, how do you get the 1 and the 2 thing? Where you like to cross out the 1 and the 2?
Well, because we're just finding, they come from here. We're just finding the factors of 2, right? Because what are we doing? And it's important to kind of just, I mean, we haven't talked about this in a while, but don't lose sight of what factoring is. Factoring is just the opposite of expanding, right? So if we know that we've got 2 binomials here, and I'm going to factor those out, I mean, think about the patterns. I'm going to distribute there, distribute there, distribute there, distribute there. I know that that last term is going to be the product of the 2 constants, for sure, right? And I know that this first term is going to be the product of the first terms of each factor. The one in the middle is going to be a sum of 2 parts, like terms. But that guy we get from him and him, and this guy we get from him and him, right? And so we know that the only convenient factors of 2 are 1 and 2. Right, so either the 2 is going to go there and the 1 goes there, or the 1 goes there and the 2 goes there. So we just tried them both out to see which one worked. Right, does that make sense? You sure? Okay. Maybe we'll do another one of those in a little bit too. Just to get a little practice with that, a little shortcut. It's not crucial. I mean, it's just a little shortcut is all it is. You don't even have to ever do that, but it's convenient sometimes. Okay, but the really key thing here is that I want you to not forget about. This has really got to stick. So turn on the super retention powers here for a second, because this has got to stick in your brain. How did we lose a solution? Because that's a big deal. Kristen, what happened?
You divided by 3x.
Okay, the dividing by 3 part was awesome, but the dividing by x part is strictly forbidden. You can never ever divide both sides of an equation by a variable, because if you do, you lose solutions, right? It's really important for us, all 3 of these solutions could be very significant depending what we're doing with this function, right? So we can't lose a solution. So this part right here, you can't do, okay? All right, so what we do instead is we factor it out front and get an easy 0 solution, okay? Make sense? So the moral of that story, factor out greatest common factors first, and typically that's going to make what you're left with a lot easier to deal with. You get smaller factors to continue on with then, all right? What about something like this? Let's just pretend this is, for the moment, let's pretend this is an equation also. So what could we do, if we do this as solving an equation? Katie, what's the first thing we would probably do? Well, you told me last time, divide both sides by 2. Should I divide both sides by 2x?
No.
All in unison, do I divide by 2x?
No.
No, we can't do that, right? So we can do that much though, and that gives us an x cubed minus 10x equals 0. Now what? Factor out the x. And then I'd be left with x times what? X squared minus 10. Do I want to try to factor that?
No.
It's not going to factor conveniently, is it? But there's no need, right? At this point, all I've got to do is apply the zero product property. And I get two simple equations that either get x equals 0, which is a solution, or I get, if I set this other factor equal to 0, well, that's an easy one to solve. That's the easiest kind, right? Because in this little mini equation, I can point to a single x. So how would I solve? Isolate it. What are the two steps? Add 10. And then square root. So what do I get?
Square root of 10.
Good. Plus or minus square root of 10. So I get three solutions. 0, negative radical 10, and positive radical 10. Right? Okay, so if we look at the factoring version of that, if we were factoring this instead, well, the only thing that would be different in our algebra, everything would be the same. The only difference would just be I couldn't divide by 2. I'd have to factor out a 2x, leaving me with my x squared minus 10. And that's where I would stop. Right? Obviously, we can't factor that one because there aren't numbers that multiply to, 10's not a perfect square. Right? Okay. All right. So why don't, before we jump onto those, why don't you guys quickly, you know what you should do? Grab the Chromebooks, and you can might as well make this a problem from your homework. So everybody grab the Chromebooks real quick and log in.
Thanks, buddy. So true. First grade is the grade that you stay on. Oh. I know, like, I figured it was like second grade or something.
So Duncan, was that a wrestling injury?
No, it was back in like second grade.
Oh,